Steps that we discussed last time. I hope now it should make more sense after your lab. And please ask questions as I move forward. So I'll be going fast. If there is anything not clear, please stop me and ask. Okay. So I have updated these slides and I have posted a new version. And these are the items that you really need to understand as a web developer. First, you need to know what is the web and HTTP, and then how to organize your code. So your code will start growing from now on. It will start to become more complex. So one way to nicely organize it is to use this MVC architecture. Some of you might be familiar with it, and I will explain what it is and how we will make use of it. Then an MVC is an architecture. You can implement it using C++, C#, any other language. In our course, we will implement this architecture using Node.js with Express package or library. Then we use this library either to build services, or what is also known as Web API or REST services. Those typically they will return to you some JSON content that you can use in another application. Or you can use it to build a web interface. And I will explain this concept of UI template. So you create a template, you feed some data to the template to generate the final page. And you can do the generation of the page either on the client side or on the server side. And finally, you see this web API that you create here, you can call it from the browser using Fetch API. So these are the ingredients you really need to know to be able to build JavaScript-based MVC application. Okay, so here is a very, very super quick review. We already seen this. I explained it through examples, and I showed you using Firefox, this utility called HTTP Fox that watches the exchanged messages between the client and the server to really understand HTTP. So understanding HTTP is a must for a web developer. So first we defined what was the web, and I explained that it is interconnected global set of resources that are interconnected. And these resources, they have a unique address known as the URL. And we understood also that the web follows a client-server architecture. So the client, typically the browser, sends a request to the server, and the server does some processing and generates some response. So it's a client-server architecture using request-response interaction model. Now for the URL, you're already familiar with it. I just want to emphasize this one more time. This is how URLs look like. You typed so many of them, and you clicked more than you typed, many of those links. And all of them, they have this format. This is the protocol with which you will be communicating with the remote server, the address of the server, the port, and followed by the path of the actual resource you want from the server. Because the server might have thousands and sometimes even millions of resources. Each resource has an address. You need to specify the address. And I explained all of this last time. Maybe one more thing just to highlight here is that in the request you can pass parameters by putting a question mark, name of the parameter, equal value. You know, this name equal value is very widely used on the web. So to pass parameters, this is how we do it. Now you might see this plus. It should not be plus. It should have been this. This is called URL encoding. These are little details that I will explain shortly. So let's see it live, how it looks. So if I just go here, again, so many things open, close all tabs. All right, good. All right, so here it is. So if I go here and then I want to search for a particular keyword, I can type it here. Let's say Qatar University. You see I put space in the URL. Space is a kind of illegal character in the URL. So when I press enter, what Chrome will do, We replace space by, what did we replace it with? Percentage 20. I'm sure you have seen this. So what we call this replacing this kind of illegal characters with equivalent characters. What do we call this? Encoding. You are a big name, just that's what it means. So if you hear this name, don't be too scared of it. Here it is. Can you see it? Oh, it didn't. Okay, maybe my URL was not correct. So let me show it to you one more time. Here is the query. A lot of stuff Google is adding that we don't care about. So let me try it one more time here. You see what the Chrome did? Let me just copy this. I think my URL here has some maybe mistake. Let me just paste it here as an example so it will work for you next time. Anyway, live editing. I will fix it. You got the idea. So this is what URL encoding. Anything you hear here is a standard. When I say standard, people set together, agreed on it. The people come after, they will follow. That's it. This is what they agreed upon. These are the characters allowed. If you have these characters, they should be replaced by these. And these mappings has been defined in a standard. And we call this URL encoding. Okay, I already explained this, that the web follows a web, it is a client-server architecture that follows a request-response pattern. So the client sends a request, the server tries to understand and make sense of the request, and we need a protocol for the server to be able to understand what are we requesting. So, and then it generates a response. So it's a request-response model. Now, for this to happen, as I explained, we need a protocol. One of the most widely used protocols on the web is the HTTP protocol. Very simple. I explained it last time. The client generates a request, and the server generates a response. So on the client, depending on what the client is trying to do, whether it's retrieving a resource or trying to update or create a resource on the server. So for retrieving, we use the verb get followed by the URL, and then we put some headers here. Like let's say the host name where this request will go to. This is the user agent. This is just saying I am using the browser that generating this request is Mozilla 5.0. Because this might be useful on the server side to say, oh, if you are a mobile device, I'll give you a different page than if you are, let's say, a desktop web browser. So, and then followed by an empty line. And then optionally, you might have some body, but usually get does not have a body. Only post has a body. But in get, you can also pass parameters if you wish. How do you pass parameters in a get request?
Name.
I just explained it.
Equal, question mark.
Yes. No, you add it to the URL. You put a question mark, name equal value. Ampersand, name equal value. You can pass multiple parameters. Okay? Now the server receives this request. It knows what you want. You are asking for this particular resource. If it finds it, it will confirm to you with the status code and then gives you the length. This is optional, content length. It tells you what I'm sending you is 54 characters. An empty line and then the body, which is the content that will be shown to the user or to the requester. So this is what really protocol is. It's just text messages being exchanged between the client and the server. So the request has a request line, request headers, and the body, which is optional. The body is really mainly when you are doing a post. When you are doing a get, there is no body attached to the request. Okay. This is, now, we can these are the most famous verbs that we use on the web. There is get and there is also post. Now, post, usually you have some kind of form. This is the most typical way of using it. You have some form, and fill up the form, you submit. So when you submit, the browser generates a request like this. So you use the verb post instead of the verb get. followed by the URL. This is the protocol version. And then the host where this request will go to. And then here I'm saying content type. This is very important. It's telling the browser, it's telling the server, by the way, what I'm sending you is formatted using this convention. You see, remember URL encoded? Mm-hmm. So basically, I am formatting the body of the request using name equal value, ampersand, name equal value, and so on. Okay. There are other formatters. I might send to the server side. I might send the JSON. Okay. So when I'm sending JSON, what will be the content type? Application/JSON. Remember the JSON format? So what do we use this header, the content type header, what it is used for? What do we use the content type for? The header content type.
You mean the JSON and URL encoded?
Yes. What are we trying to tell here to the server?
200.
No. Sorry.
Maybe
What we are sending, more precise? Format of the type. Yes. The format of the data in the body of the request. We are telling the browser, no surprises, we are not throwing things at you and you figure it out. We are helping the server side saying, oh, by the way, when you go to the body, what you will find there, you will find in this case, this form encoded format. This form encoded format, again, it's standard. Standard for all the web, for it to work, it must be standardized. Otherwise, it will not work.
So who sends this? Who generates this information?
Very good. Who generates this line here and this information?
The HTTP.
the user.
No, not the user. HTTP.
Who generates this? Who generates it? In this case, when you see this in the browser and you press submit, who generates all these requests? Which client in this scenario? When you see a form and you submit the form, who generates the HTTP requests? The browser. That's it. It's simple. The browser generates this. Okay. Now, of course, you can write JavaScript code to do this by yourself, and that's what we will see later on. Remember when you have that drop down of country and cities? Yes. Later on, you don't let the browser do it for you. What you will do, you watch for the country change event. Whenever the country change, what you will do? You will do a request to the server to get the cities or the states of that country. Okay? But in here, by default, if you just have a form, you fill up the form, you press the submit. Who generates this request? The browser. And the browser knows. It knows what to do because it is HTTP client. It cannot call itself a browser if it does not understand HTTP. And the server side that cannot call itself a web server unless it understands HTTP. Okay? So it is clear what's going on here. So post is to send some input to the web server for it to do something with it. In this case, we're asking the server to do some computation. We might ask it to create, let's say, a book or get a list of books or do whatever, register a course, get a transcript, whatever request might be. It's clear the difference between the get and post. And in both of them, you can pass parameters. But how do you pass parameters with get request? In the URL. These are some of you ask what are the exam questions. Those are the exam questions. Okay? How do you pass parameters with the get request? In the URL, because the get request do not have a body request body. What about the post request? Sorry? Where do you put usually the parameters or the data you send into the server? In the body. No, in a request, yes, it is in the form. Visually, it is in the form, but when you submit the form, what will happen? The values you have entered will be formatted using this form encoded format. In this case, this format says, take the name of the input equal the value, ampersand name of the input equal value, and then put it in the body of the request. Body means this is the text. Just put an empty line, make sure there's an empty line, and then you put the body in there. Yes?
So the browser creates like a file with a header and body?
Not file, just a string. Create a string and send it off to the server. Yes? And if you want to see that string, there are utilities with all browsers to see those exchanged messages. Plain text messages. Yes?
Yeah, what is the difference between post and use? And then
Post.
how to use.
That's different. I will explain that one. Now, basically, the HTTP verbs are standard. We cannot add any other verbs. What are the major verbs we have in HTTP? Get, post, put, delete, and there are others that are not. There is no update. No. There is post, put, and delete. That's it. There is no use. Use is something related to Node.js Express. I will explain what it means.
Is also update, but
There is no update in. If you want to update, which verb you typically use? Put. If you want to create or add, usually you use post. There are some more differences. I will not bother you with them now. Later I will explain them. But for now, if you want to read or get something, which verb you use? Get. If you want to create something, you post. If you want to update something, put. If you want to delete, delete. So remember, a web is a set of resources. How do you interact with these resources? Using verbs. Get to get a representation. Post is to create a new resource. And put is to replace or update the resource. And delete is to delete the resource. Because resources, they are not eternal. Maybe I'm just thinking aloud. If you no longer say a certain book, you can delete it from your catalog, for example. It's just,
Why did you post update resource during this class?
in here, we are not updating a resource. Yes, you're right. In here, I'm using it to like basically send input, and the server side will do some computation. But typically, in most applications, in many cases, we will be creating some resource or updating some resource. For example, when you register a course, you are basically creating a course registration resource. Yes? Well, you can drop that course. You are deleting that resource. So remember, a resource is a very abstract concept that encapsulates anything. Page, image, video, a record in a file, a record in a database, all those are objects. And how do we interact with objects? How do we read them, update them, delete them? Using HTTP verbs. Now, in the URL, this is very important remark. In the URL, you never put verbs. URLs refer to resources, and resources are nouns. So let's say you have let's say you want to update a student. So what you do a post to /student/the ID. You don't put in the URL update students in the URL. The URL should all have nouns, not verbs. Where are the verbs? You decide the verb in the request type, whether it's get or post or put or delete. Yes? But the URL should not have verbs. The URL should be nouns. Because resources are nouns, not verbs. But we interact with them using verbs. That's the idea. Okay, this is the request, this is the response. So the response, it gives you some status line, 200 OK or 404 not found or whatever. And then some headers, I will show you some examples, and then an empty line and the body of the response. So here is an example. In here, for example, remember this was the request for this guy. This was the request. Remember? This was the request. I was very nice with the browser, with the server, and I told it, oh, by the way, the length of this one is 27. And by the way, I'm sending you this encoded in form URL encoded. The server, إذا حييتم بتحية فردوا. فحيوا بأحسن منها أو ردوها. This is what it's doing. It's not just sending you, here's the reply. It's also very nice. It is giving you some status code. Saying, oh, by the way, I understood what you talked, the protocol you have used to talk to me. And by the way, I am also talking back to you using the exact same protocol. And I congratulate you. Everything went fine. And then, by the way, you will find that in the body, I am sending you some content. I am helping you not to wander around and say what type of content. I am telling you explicitly what type of content this server is sending.
Calculations. Oh yeah,
Text, this is the type and this is the subtype. Remember? This is the type / subtype. That's how we define the content type. So in here, what is the body? What does the body contain? It's text. But what type of text it is? It is HTML. Very important, these content types. So the browser is ready. Say, oh, by the way, I'm expecting an HTML page, so let me be ready to render it and show it to the user. If it's a video, let me bring in the video, be ready to play the video. So always, when the server sends the response, it sends also the content type. This is one of the important headers that comes back with the response. So you see here, the client is very nice to the server, saying, okay, by the way, I'm sending you the body, and this is the format of the body. And the server is also responding nicely also with explicitly saying, oh, by the way, I am sending you text and subtype is HTML. And it says, my name is QU web server. And by the way, what is the length of this body? 131. Yeah? This is optional. The browsers, by the way, the browsers are very smart and you throw at them anything, they will try to handle it. But it will be nice to tell them explicitly what's going on. So even if these two are not there, don't expect the browser to be confused. It knows what to do. But it's nice to have this stuff explicitly. Okay, it's clear how the response looks like. It's plain text going back and forth between the client and the server. Yes, yes, please.
What is the browser? What does the browser has to understand all that stuff?
What the browser has? Okay. So the browser is, as you know, is a piece of software typically written in C++. It understands how to create HTTP requests. It translates your actions that you do on the browser into HTTP requests. When the response comes, it understands how to show it to you. It understands two things. The browsers understand many things, but among them, HTTP protocol is a must. Then they must understand what else the browsers are able to understand.
User.
Oh, HTML. They are able to understand HTML. What this tells the browser?
It's a head, the title.
This is the title of the page. It will be shown in the tab. You know those tabs? I have so many open last time. The name of the page will be shown in the tab. It will not be shown in the body of the page. It knows that this one will be, what the browser will make this? A link. You see? So the browser understands HTML, it understands CSS. It's also able to run JavaScript. It's very smart kind of or powerful piece of software being able to do all of this. Yes?
HTTP is the only protocol that we have?
The major protocol for the web, yes. There is also FTP, file transfer protocol, to exchange files. But for web development, these are not relevant. Okay? All right, now the status code. Remember the status codes? So there are many status codes, and they are categorized into 5 kind of classes. If you see a code that is in the 200s, be happy, everything went fine. Let's say in this case, 200 okay, everything fine. 300, it means a redirection. Let's say you have some employee, like let's say Fatima, and they left, they no longer work with you. So they had a URL before. So you can configure the server to say when somebody comes to /Fatima, send them to cmu.qa, for example, /Fatima. And then basically the browser will redirect. I'm sure you have seen this. You visit some page and the browser redirects you somewhere else. How does it do that? Through this header, 300 header. Usually the 302 not found. Found, but it will tell you the location where it's found. It tells you basically you came to the wrong address, go to this other URL. 400, usually it's an error caused by the client. The client is requesting something that does not exist. They try to access something they don't have access to. 500 is the server to blame. Server crashed, server is no longer responding, is busy, whatever. You see very nice coding. You can see the people behind this HTTP, they really thought about it very, very, very nicely. Designed many years ago, and maybe 20 years or more. It's widely used and people use it. It's so nice and so simple. It's clear, the status codes. Maybe for us as web developers, this is important to know, because I will show you some examples where sometimes we need to send those codes. Maybe I'll show you, since we're talking about them, I'll just show you a small example. So here is my app. Okay, maybe I'm not, let me see. Okay, here. So in here, I'm trying to add a hero. I hope everything goes okay. Otherwise, I will send the status 500. And I will be there. You get the idea. So this is a nice thing. If somebody, let's say, looking for, I'm not doing it here now. Oh, this is good. This is not so perfect. I should have said, if some error happens, I send 500. Otherwise, if I tried and it did not find what you were looking for, I give you back 404 not found. Okay, so I can make use, as a developer, I can make use of these status codes to inform the requester. Okay, these are the most famous status codes: 200 OK, 301 moved temporarily, 400 bad requests, unauthorized, and so on. Okay, I'm sure you have seen some of them, especially this one, quite famous. No, you don't need to memorize. You need to understand. This course, there's no memorizing. You need to understand. When you want to, but this you need to understand. Memorize whatever you. This one is a must. I'm not expecting you to know what is all the 200s, but you should know that 200, it's green. Everything is fine. 300, something is a redirection. Something has moved. 400, an error, client to blame. 500, error, server to blame. Very easy. Now the details you don't need to know, but this you must know. This is the minimum. Okay? The other ones you will know them as you use them more and more. Okay, this is the example of redirection. Somebody is asking for some URL that has moved. What the server will send, it will send 301 moved permanently, and gives you the URL. Okay? So let's say QU was part of another organization, and now it is independent. When somebody goes to /QU, they will be redirected to QU website, as an example. But it's more realistic when you have somebody with you and then they moved. You can, instead of say, we don't know this guy, he's no longer with us, you can be nicer and say, oh, we know where he or she, and you basically redirect them. Okay, the internet types, I explained those types, content types. There are many content types, and those are also standardized. So for example, this is, if you want to send JSON, the content type will be application/JSON. If it's a GIF, it will be image/GIF, image/PNG. So you can always see type/subtype, type/subtype. That's how it works. Even text, it could be XML, it could be plain text, it could be HTML, it could be plain text. So very nicely done. If you want to know all the types, you can look at it. But you must know HTML, JSON, heavily used. You must know these two types. These three, at least these three. Okay, now, the typical way the servers process requests. Basically, they receive a request as text. They will try to parse it or to convert it to an object. They try to extract from it the input parameters and so on. Luckily, you don't need to do all of this. A framework like Express does all this for you and gives you two objects, request and response. You use the request to read from and the response to send the response. And then you run some code to generate the response and then you send it back. This is the typical way, but the frameworks like Node.js Express makes this much, much easier to do. But I just wanted to tell you in high level how web servers really work. Okay, so now we understand the web, we understand HTTP. It's time to start building some useful web applications. So, slowly this application will grow and become complex. So from day one, we'll try to organize them in a nice way. So one way to organize them is to use this architecture called MVC. What MVC stands for? Model View Controller. What does it say to us?
One for the server side.
What is one? What do we mean by one?
The view.
What do you?
Like the
So no. First, what is an architect? What do we study architectures for? And what's the idea?
The designer.
Yes, design. Yes. So now I know MVC. What does that mean to me?
Like everything has its own thing. Like for example, the controller controls the code and controls the page. The
Okay.
view is the design of the page.
Okay.
The model is, for example, what type of things are included for the controller to control.
Okay.
Just
Okay.
thinking
Close.
out that.
A bit close. That's fine. So basically, what an architecture really tells us to do, it gives us an idea how to organize our code. So what we do, we take our code, we divide it into three major pieces, and we give each piece a role, a particular responsibility. So we have the model. What is the role of the model? Sorry?
For the data and the classes.
For basically doing all the computations, including reading and writing data. Okay? So all the computations should be in a separate classes or files or scripts, and all the reading and writing should be separate. And then what about the view? This is the user interface to receive input from users or to display the results to users. What about C? The controller. What does the controller do?
The connection of the functionality. And they organize the.
Very good. Is the connector.
Between the model and the view.
Okay. So what is its role? One word, one verb.
Interpret the model into view.
Sorry.
Interpret the model into routing.
Interpret. Yeah, there is a front controller that does routing. Very good. Remember routing. What is routing? It's not the router you've seen in the net. Routing here, what it means? Mapping a URL, a HTTP verb, and a URL to function. You've seen this in the lab. That's what the router is. Okay. Now, the controller is basically does the coordination. Controller, all the controller do is coordination. So let me give you a small example. So for example, let's say the dean asks the department, please give me the budget for this year. How much money you need to run this department? So this request will come to whom? So the dean wants the budget for CSE department. This request should go to whom?
The financial department.
No, this is the department level. It tells you how much you need. We do this in real life. Like a department needs some money to run. So they need to allocate some money to the department. So the dean every year asks whom? The head. Thank you. So the head is basically the coordinator. They receive these requests, and then in this example, the head will ask every member to say, do you need any equipment? Do you need any software? Do you need any travel? Do you need any... And then basically she collects all this and compile it in one big report and send it off. So the request comes to the controller. The controller coordinates the steps to achieve the goal, and then get the result and send it off to the requester. So it's the coordination. Yes. So for example, when you book a ticket in Qatar Airways, as an example, so there are multiple steps when you press that button. So your credit card needs to be charged. Your seat will be booked, so nobody will take it. Then a notification email will be sent to you. So at least these 3 steps, let's say. So who coordinates these 3 steps? The controller. And the controller might talk to multiple models to achieve the task the requester is asking for. Yes, it's clear? So the coordination logic, the steps, coordination, the steps, who takes care of it? Where do we write this coordination logic? Controller. Anything to do with the interface? View. Anything to do with computation, reading, writing data? The model. Is clear? Why do we do all of this?
We have to know.
For readability, simplicity.
For it to make it first simple, because you will be starting to build large applications, you need to be organized. Second is you separate concerns. You separate. So you can change one without affecting the other. And the third thing is the model. You can share the model between multiple views. You can have a mobile view, and you can have a desktop view, you can have a web view, same model. So for example, QNB, or let's say, or Facebook, you can use it through the browser, through a web app, but the actual model, the one that does the computation, the reading and writing, is the same, it's shared. Okay? So for example, you try to log into QNB website, and then you say, oh, it didn't work. Let me try the mobile. You try to log in there. It will not work also. Because why?
The same model.
They're sharing the same model. Different interface, same model. So if you put the computation with the view, it's very hard for you to put another view. Yeah? So if you put things together, it's very hard to understand, very hard to maintain, very hard to develop, and so on. But with MVC, it's much, much easier. So this is how typically things work. So the request comes, there is an entry point front controller. This is your app.js. This one does the routing. This one will do the routing. It will say, if somebody comes to this URL using this verb, this is where they should go. Or this is the function you should call. Now, in your application, you might have multiple controllers. One controller, let's say for banner. One controller for courses, one controller for schedule, one controller for transcript, different controllers for different things. Now, these controllers will talk to one or many models to read and write, to do the computation. These models will talk to the database. We never get the controller to talk to the database. We never do that. Okay? Or even worse, get the view to talk to the database or talk to the model directly. Like basically an architecture gives you an idea how you break down your project or your solution into pieces and puts on you some rules. So this is the communication. You should not cross. You should not get this to talk directly to the data source. Okay, and then the controller, once it gets the data, it will choose a model, choose a view and send it off. Generate the view, generate, in our case, HTML or JSON to send it back to the requester. Yes? Okay, so let me show you this concretely, how it looks. Although this code is still not very well organized, but I will organize it a bit more. Maybe I'll break this solution into two, because here I have two examples, student example and hero example. Maybe you did the hero example in the lab? Which example did you do? Student example. Okay, that's fine. Okay, so in here, I have this, what is known as the front controller or the router. All the requests will start and come to this app.js. And then it says, okay, you came to, using a GET request, you came to this URL. So I will send this request to a controller called hero controller. Which method in this controller? The get heroes. I could, of course, I could here put all the code to do the work, but that's not MVC. Controller should only do the routing. No, sorry, here it's not even, this is called the front controller. I have only one front controller for the whole application. All it does is route. And then the controller will say, okay, you want me to get the heroes, no problem.
What is the implementation of hero controller?
Sorry?
The implementation of hero controller.
Here, I'm going to it. Okay. Here, it's a class. I don't need this. Okay, it is a class. So here is the get heroes. So I will go, again, I will go to the repository to do it. Now you will say, oh, I have too many layers. Here, because it is simple, one step to achieve the goal. But in realistic application, you might do multiple steps to achieve one use case or one goal. I gave you the example of booking a ticket. So you have at least 3 steps. Charge the credit card, mark the seat as reserved, and notify the customers. 3 steps. So these 3 steps are 3 calls to 3 models. But these 3 calls, I put them in the controller. So the controller never does the work. A good boss is not the one that when a request comes, they will go and do it. No, no. A good boss is the one that coordinates and facilitates and delegates. Okay, and then when the work is done, they verify, bring their nice pen, sign it, and send it off. Okay, but they don't do the work. So that is the idea of the controller, yes? And then, now, the one that will actually do the work is the model. So in here's my model, which is in my case, I called it a repository because I read and write from a data source. I don't have much computation here. So here is the repository. I'll go there. It's a class. And this one will do the actual work. So it's one to the database and gets me the data and return it as JSON. In here, it's one to the file, it's filtered, and return me what I asked for. You get the idea. So the model, in our case, a repository, is the one that actually do the hard work. The controller is just coordinating. So this is how you break down your application. Now, let me show you the last thing. So in this, let me see this get hero. Okay. Let me see. Okay, all these don't have a user interface. Let me show you another one that has a user interface. Not very nicely organized, but let me show you. Here is one. Here is one. Here is one. Okay, sorry, just a second. Okay, where is it? Render. Can somebody see render? Okay, just render. Yes, here it is. Okay. So, in here, if somebody comes and say, they came using a post request, they came to the slash. What I will do, I will ask the repository to do some work, and then I choose a view. There is a student's view. A view is nothing, I will explain this next time, but let me show you what a view looks like. A view is nothing but a template. So a view, I'll give it a list of students. It will go through them one by one and display them as a drop-down. So anything to do with displaying the results or having forms to collect the input from users, where do we put this? In the view. So you see here the separation of concerns between the model, the view, and the controller. So let me just wrap up here. This is the role of each one. The controller does the coordination, receiving the input, talking to the model to do the work, and choosing a view, and then returning the view to the caller. Now the model does the actual logic, the actual computation, the actual data retrieval and update, and the view is just the user interface for getting input and displaying the results. Now these are the benefits that I explained. And one more thing, you can do things in parallel if you do model view controller. If somebody is very good with CSS and HTML and making things look nice, you give them to do the view. Somebody good developer, you give them to do the model. That's the core of the application. And the controller is kind of a middle developer. They don't like developing too much, but they don't like the view as well too much, so you give them something kind of in the middle, just to coordinate.
So I usually define 3 classes.
Sorry?
I usually define 3 classes, one for the model and one for the...
Yeah, typically you define view, which is typically just a page. The controller, usually we have one controller for a major part of your application, and the model you might have multiple models. Multiple models. You can have, let's say for banner, you can have one for students, one for schedule, one for... So I will explain this more. So I hope now you get the big idea, because last time you kind of seen it practically, you went and did some work, and now we came back and gave you the big picture, how really things fit together. So inshallah next time, I will go through and review this, express what you did in the lab, and build on it to create this MVC. Because so far you've seen a bit of controller, you've seen a bit of model, but you didn't see the full end-to-end. So inshallah next time you will see full end-to-end, and then you practice it in the lab. Okay, thank you.